Hello, everyone. My name is Alex Sherrod, and I'm with Precision Pipe and Products, and I'd like to welcome you as we begin our two-part series on culvert rehabilitation and the slip lining process. As we begin, I'd like to say that there are estimated to be 4 million culverts across the United States, many of these having been in service up to 70 years. Due to factors of material decomposition, storm weather events, and extended service life, many of these culverts have experienced a severe loss in performance and structural integrity. Today, we will explore the following questions to get a better understanding of the important role culverts play in maintaining a healthy roadway infrastructure. Our first learning objective will be to define what is a culvert. What causes culvert deterioration and failure? What are the visual signs of a failing culvert? And lastly, how do we prevent culvert failure? So our first question will be to define what is a culvert. When we hear the word infrastructure, most of us think of roads and bridges or railroads. However, supporting these roads, bridges, and rail lines are countless drainage structures that are classified as culverts. They are buried pipe, box, or arch structures that are open at both ends to convey water under the traveling surface. They can be structurally similar to bridges, but are defined as having unsupported spans of less than 20 feet. Culverts really can be classified into two major types. The first one being a rigid culvert, where the structure is required to handle all the pressure loading from the surface traffic and the surrounding soils. The second culvert type is the flexible type, where this structure interacts with the surrounding soils to support the load requirements. Rigid culverts come in several different shapes due to the nature of the material used. They can be round, boxed, elliptical, or arched, or a combination thereof. Flexible culverts, however, predominantly come in the round shape due to the limitations of common corrugated metal or corrugated plastic pipe. And rigid culverts can be made from steel, concrete, plastic, or rock masonry materials, which you can see here by these two pictures, an example of each type. Top one, we've got a standard round corrugated metal pipe culvert. And the bottom here, we've got a arched masonry or rock culvert that may actually be serving two purposes, and not only transporting this, displacing this body of water, but also serving as a bridge function. So what is the objective of culvert rehabilitation? Well, it is to take maximum advantage of the remaining usable structure in a culvert to build a reconditioned structure with little to no impact on the roadway. We can see here by these two examples, we've got two concrete culverts that have both been rehabilitated with a smooth wall carbon steel slip liner. This first culvert here was located in Fayetteville, North Carolina, and the one on the right was located in Waynesburg, New York. These are two projects that we worked on. And again, notice that culverts can serve multiple purposes. Not only is this culvert displacing the body of water, but it is also being utilized to as a traveling surface for the motoring public across that waterway. So what causes culvert deterioration and failure? Well, there are several factors that can lead to culvert deterioration. The first one we're going to cover is scour. Scour is created from soil conditions and common sediments that, when carried through the culvert, act as an abrasive to the bottom invert of the pipe. And if this goes unchecked, as we'll see here shortly, it can create major problems for that pipe material. Now, additionally, rainfall, flooding patterns, and other storm events can expedite culvert failure if the water is unable to flow through the structure under the design parameters. This is due to the increased hydraulic pressure that builds on the upstream end of the pipe. These factors will lead to an increased likelihood that the culvert will fail if the structure is not inspected and documented accurately and regularly. So as I mentioned before, one of the most common problems with corrugated metal culverts is deterioration of the invert, usually due to a combination of corrosion and abrasion. The continuation of this abrasion, if unchecked, will lead to a loss of the invert and the creation of voids under and around the culvert. These two pictures here give a great example of what that abrasion looks like to the bottom invert of the pipe, and that can be caused again by scour or other sediments and material that are carried through the pipe. And we see over here a large void has been created under the culvert. This culvert is no longer effectively displacing that body of water. And since a corrugated metal pipe is classified as a flexible structure that does require interaction with the surrounding soil for stability, loss of the invert can result in severe distortion and collapse of the culvert. And that's exactly what we see going on here in this corrugated metal pipe culvert. We see distortion, and this culvert is beginning to collapse as the structure is no longer able to meet the structural requirements to hold back the weight of the surrounding soils and the surface above. Here we've got an example of a 138-inch round corrugated metal pipe culvert that is 51 feet in length, and it was located here in Birmingham, Alabama. And you can see from the close-up picture here, again, this culvert has experienced severe abrasion and corrosion to the bottom invert of the pipe. And we can also see a lot of common materials being rock and wood or branches that are carried through the stream have gotten lodged in these voids. So now we're going to take a look at this quick video showing what happens to that water when the invert is no longer present in the bottom of the pipe. We can see that the water begins to travel through the culvert, but now with the void, the water is no longer inside the pipe, and it is actually taking the path of least resistance and carving out its own new path underneath the pipe structure. So to get a better understanding of the performance metrics of common culvert materials, Caltrans, California DOT, conducted a research project 2001 to 2006 to capture and evaluate the level of resistance to abrasion of the most common culvert materials and coatings. They conducted this test at a real-world site and evaluated 17 different materials over this 5-year period. The materials consisted of concrete, plastic, steel, and common pipe coatings. Taking a closer look at our data, the blue graph depicts wear rate in millimeters recorded for each material type. It was found that during this 5-year period, smooth wall steel plate recorded the lowest abrasive wear, while pipe made with calcium aluminate had the highest. We can see steel plate listed here on the far left. Again, this blue graph is showing us the wear rate measured in millimeters per year. And to the right, on the far side of the graph, we have calcium aluminate, showing it had the greatest wear rate recorded in millimeters per year. We should also note that eventually any coating can be eroded or broken away, and that this abrasion can accelerate the corrosive conditions to the pipe. So in 2015, Caltrans conducted a follow-up study to test the destructive resistance of steel pipe. And this study tracked the corrosion rates of steel pipe exposed to corrosive soil, water, and marine conditions. This study recorded that steel corrosion rates vary depending on the environment. And steel pipe can be used in corrosive soil or water environments provided that adequate mitigation measures are in place. The department cited that sacrificial metal be incorporated into the design of the pipe wall thickness to compensate for the loss of metal that occurs due to corrosion. This extra metal thickness is added to all surfaces of the pipe that interact with the soil and water. So we can see, as they've defined it, they've classified three different major environments: a soil embedded zone, an immersed zone, and a splash zone, wherein they calculated an estimated wear rate of 0.001 inches per year to the outside of the pipe. This is the corrosive rate that the pipe would experience in this soil embedded environment. And as the environment moves to a more corrosive environment, that factor goes up. Again, the importance here is to note that this was determined to be compensated with incorporating sacrificial steel into the overall wall thickness of the pipe. Here's wanted to review this real quick. As a steel, these pictures show a steel pipe liner that was used to slip line 2 round culverts right outside Richmond, Virginia on I-295. And we take a closer look at the micrometer reading here to the right. After 25 plus years of being in the ground and being exposed to water and other conditions, the pipe shows no recorded loss of wall thickness, and this micrometer reading is still showing at 0.589 inches. So what are the visual signs of a failing culvert? Well, there are several signs to be aware of that indicate your culvert structure may be underperforming or close to failure. So our first sign is excessive water backup on the upstream end. That would indicate flooding. And the ability of the pipe to carry water is diminished. And it also can indicate that it's beginning to cave in or close up. So the pipe is no longer meeting the design hydraulic capacity requirements. Our second sign is that the road above may begin to settle over the path of the existing pipe. And in this case, we may see cracking in the pavement or the roadway. Our third sign is the head wall may begin to move away from the existing pipe at the downstream end. This case, we call what the culvert is beginning to float based on water movement, and also that the backfill material around the pipe at the downstream end may actually be beginning to erode or wash away. And finally, if our culvert and roadway have washed out during a storm event or snowmelt runoff, then we would have a total catastrophic culvert failure. So we're going to play a video to see what exactly that would look like. We can see that that water pressure on the upstream end is now overtaken the culvert, and it's beginning to pull the top of the roadway into the structure. And as that pressure builds and that weight builds, you can see it is just sucking this asphalt surface into the void where the culvert existed. And there, our roadway is completely gone. Water continues on the path of least resistance, and we have a failure, a complete failure of the culvert. So how do we prevent culvert failure? Well, to ensure that a culvert system is functioning safely and effectively, inspection should evaluate the following. structural integrity of the culvert, the current hydraulic performance, and the roadside compatibility of the structure. Inspectors across the organization should be trained to identify and monitor the common signs related to culvert failure. Records should be kept detailing the design's service life and present site conditions. So the surefire way to monitor a culvert's conditions and to prevent a failure is through methodical and timely inspections. So in summary, we first defined what is a culvert. They are buried pipe, box, or arch structures that are open at both ends and convey water under a roadway. They are defined as having unsupported spans of less than 20 feet. What causes culvert deterioration and failure? Well, common factors include scour created by sediment and soil conditions, decreased hydraulic performance if that culvert begins to cave in or close up, or corrosive site. What are the visual signs of a failing culvert? Excessive water backup or flooding, roadway settling or surface cracking, or a floating structure that would indicate water has now gotten in between the culvert and the surrounding soils. So how do we prevent culvert failure? Through methodical and timely inspections. I'd like to thank everyone for joining us in part one of our discussion on culvert rehabilitation and the slip lining process. Again, my name is Alex Sherrod. I'm with Precision Pipe and Products. And I'd like to welcome everyone in part two, which we will discuss the common trenchless rehabilitation methods and the slip line installation process. If you have any questions, I have contact information listed here, and I look forward to seeing everyone again soon.